Good morning, student. In this video, I will be discussing about what are the most important topics which you will prepare for your upcoming CBSE board exam, class 12 chemistry. So from my 15 plus years of experience of teaching chemistry, I've seen a lot of changes CBSE has undergone, particularly with the level of questions they ask, the different types of questions they ask, and everything. So particularly, I see that there are MCQ questions which will be asked from all the 10 chapters, three in physical chemistry, solutions, electrochemistry and chemical kinetics, two from inorganic chemistry, the D and F block, and coordination compounds, and five chapters from organic chemistry, namely haloalkanes and haloarenes, alcohols, phenols and ethers, aldehydes, ketones and carboxylic acids, amines, including diazonium salts, and biomolecules. As you all know, few chapters has been deleted, like solid state, surface chemistry, metallurgy, P block, polymers, chemistry in everyday life. These are the chapters which has been deleted from the CBSE syllabus. So now coming to the very first chapter from solutions. So solutions, you have to basically know what is molarity, what is molality, and what is mole fraction, along with parts per million, parts per billion, uh, as well as you have to know the colligative properties, different colligative properties like relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure, and including the Van 't Hoff factor. So you have to know how to solve the numericals based on them, along with some concept-based questions like agiotropes, reverse osmosis, etc. So numerical forms the core of this chapter. So you must know how to solve the numericals based on colligative properties as well as the concentration units. Now coming to electrochemistry part, you must know how to solve questions based on EMF and how to apply Nernst equation. You must know some values from logarithm, like log 2 is 0.301, log 3 is 0.477, log 5 is around zero point 0.7, log 10 is like 1, log 1 is 0, log 10 to the power x is x, and how to convert ln x to log x. So ln x is equal to 2.303 log x. So these are the simple values of log which will help you solve questions based on Nernst equation. And then you have to know what is Faraday's laws, the first law, the second law, and numerical based on them, and numerical based on them. Nextly, you have to know what are resistance, resistivity, conductance, conductivity, molar conductivity, limiting molar conductivity, how to calculate molar conductivity of particular electrolyte using Calder's law of independent migration of ions, how to measure the conductance of a electrolytic solution. With the help of Wheatstone bridge, you can calculate the unknown resistance, and simple concepts like fuel cell, different types of battery, the primary batteries, secondary batteries, and their anode and cathode reaction, including rusting of iron, that is corrosion. Now coming to chemical kinetics, which deals with the rate of chemical reaction. What are average rates, instantaneous rate, and coming to how to write the rate of a reaction. What is the unit of rate of reaction, like mole per liter per second? What is the unit of rate of reaction when gaseous reactions are involved, like atmosphere per second or bar per second? How to measure the time period, time taken by a first order reaction to occur? What is the formula to calculate time for first order reaction? T equal to 2.303 by K log R naught by R. What is half life? How to solve questions in based on half life, and even unimolecular reactions, like reactions where molecularity is high but order is one, like hydrolysis of ester, hydrolysis of sucrose, hydrolysis of alkyl halide. These are pseudo unimolecular reactions. And then also regarding zero order reaction and first order reaction, you have to know the examples of those reactions. Along with Arrhenius equation, K is equal to A e to the power minus A by RT, and collision theory. All the some numericals will be asked from your Arrhenius equation based on the logarithmic equation, like log K2 by K1 is equal to EA upon 2.303 R 1 upon T1 minus 1 by T2. So you must know these things. This will be quite helpful. So you must have a thorough practice of NCERT book along with the in-text questions, examples, as well as solve. And if you can do the exercises question, that will be icing on the cake. Now moving to inorganic chemistry D block element. So you must know how to uh, write the electronic configuration of 3D series N-1 D1 to 10 NS 1 to 2, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You must know the pseudo transitional element like zinc, cadmium, mercury. You must know the unique configuration of chromium, copper, whereas copper 1 is stable or copper 2 is stable. And you have to prepare KMNO4, K2Cr2O7 also. How they are prepared, how they react, what is their reaction in acidic medium, neutral medium, alkaline medium, what is their equivalent weight, how is their oxidizing nature and uses also. Why KMNO4 and K2Cr2O7, despite having no unpaired electron, they are colored. So you must know the reason, charge transfer spectra. Coming to the properties of transition elements, like they exhibit color, they are paramagnetic due to presence of one or more unpaired electron. They form complex compound because of their small size, high charge density, and availability of vacant d orbital. They form interstitial compounds like borides, hydride, carbides, nitrides, etc. Uh, the compounds are colored due to redet transition. And similar properties like electrode potential, etc. Why Mn2 plus is stable, which one is reducing, which one is oxidizing. Then come to F block elements like cerium so plus 4 state, and the elements and their configuration. That much is enough for D block. Coming to coordination, which is very important chapter, you must know how to write the name of a complex, how to find the oxidation number and coordination number, what are ambidentate ligands, like cyanide is an ambidentate ligand, nitrito and nitrito O, thiocyaneto, isothiocyaneto. Isomerism in coordination compound is another important topic. And coming to VBT theory, you have to know what will be the hybridization, whether it is a weak field ligand, strong field ligand, what is the number of unpaired electron, whether it will be paramagnetic or diamagnetic, what is the shape of the complex, whether it will be tetrahedral or square planar, coordination number 4. Along with your CFT, crystal field theory, how to write the configuration in the form of T2G and EZ level. Now coming to organic chemistry, like particularly haloalkanes, haloarenes, you have to know how to write the IUPAC name, how to write the isomers, like the isomers of C5H11Br. There are 8 isomer structural isomers. You have to write them. You have to know which one is primary alkyl halide, which one is secondary, which one is tertiary. So based on this, you can just solve questions. You have to know the reactions like Woods reaction, Woods-Fittig reaction, Sandmeyer reaction, Gattermann reaction, uh, Finkelstein reaction, Schwarz reaction. These are reactions of halogen exchange. And simple conversions based on this. And you have to also complete the reaction with the major product. You have to know Markovnikov's rule, anti-Markovnikov's rule, Sadzev rule during elimination reaction. What is Hoffman's rule? So these are particularly most important topic from haloalkanes and haloarine. Coming to alcohol phenol ethers, you have to know what is primary alcohol, secondary alcohol, tertiary alcohol, what are monohydric alcohol. You have to know the example of a dihydric alcohol like ethylene glycol, trihydric alcohol like propane 1,2,3 triol, also called glycerine or glycerol. You have to know what is Lucas reagent, anhydrogen chloride and uh, conc HCl, which is used to distinguish between 1 degree, 2 degree, 3 degree alcohols. 1 degree will not react at room temperature, whereas 2 degree will give turbidity after 5 minutes. 3 degree will react immediately. You have to know about phenols, how phenol is prepared from cumene, how phenol is treated, how phenol is converted to benzene by using zinc. What is the oxidation reaction of phenol? How phenol reacts with nitric acid, dilute and concentrated. How can ortho nitrophenol and para-nitrophenols be separated? Then you have to know the acidic strength of phenol and ethanol. Phenol is more acidic than ethanol. It is actually a million times stronger because the phenoxide ion is resonance stabilized. Also, you have to know the ether, particularly from ether Williamson synthesis and how ether reacts with HI. And so different reactions are there. You have to know that in Williamson synthesis, the alkyl halide choosing is primary, not secondary and tertiary, because in case of secondary and tertiary, elimination occurs and alkene is the major product rather than ether. So these are the particularly most important topic, and also along with that, to name reactions are very important, like Riemann-Tiemann reaction and Kolbe reaction from phenol. So these are the, or you can also prepare aspirin, how aspirin is prepared, what are the uses of aspirin, like it is a antipyretic, analgesics, anti-inflammatory, also having blood anti-blood clotting ability. So these are the uses of aspirin, 2-acetoxybenzoic acid. Now coming to aldehyde ketones and carboxylic acid, which is the most important chapter from your organic chemistry, with a lot of name reactions like Rosenmund reduction, converting an acid chloride to aldehyde using palladium barium sulfate. ETAT reaction where you convert the toluene to benzaldehyde. You have Stephen reaction converting nitrile using stannous chloride and HCl to form imine, and then particularly hydrolyzing that imine to form aldehyde. The reductive specific reduction using diol H, diisobutyl aluminum hydride, converting nitrile to aldehyde and esters to aldehyde. Uh, Another important topic from aldehydes and ketones are like aldol condensation. Aldehydes and ketones having alpha hydrogen undergo aldol condensation. And Cannizzaro reaction. Those aldehydes which do not have any alpha hydrogen undergo a disproportionation reaction. One of the molecule is reduced to alcohol, whereas another is oxidized to carboxylic acid salt. You have to also know what is Tollens reagent and what is failing solution, how they help distinguish between an aldehyde and ketones. Also, the characteristic reaction of aldehyde, nucleophilic addition reaction. Also, reaction with ammonia and its derivative, how you will eliminate one water molecule to form the product. Like hydroxylamine will form oxime, hydrazine will form hydrazone, semicarbazide will form semicarbazone. 2,4-DNP is also called Brady's reagent, how it will react with an aldehyde or ketone. Coming to carboxylic acid, the most important topic being the acidic strength of carboxylic acid and related compound. Why carboxylic acids are more acidic than phenols? How you can distinguish phenol and benzoic acid? So phenol and benzoic acid can be distinguished by using uh, sodium bicarbonate. Brisk effervescence is seen in case of benzoic acid, but phenol being a weak acid is unable to give this reaction. From carboxylic acid, some few reactions are also important, along with HBZ, Hell-Volar-Zelensky reaction, which is quite an important reaction for your exam point of view. Coming to amines chapter, which is a very beautiful chapter, you have to know how you can convert nitrobenzene to aniline using hydrogen palladium, tin HCl, iron HCl. What is ammonolysis? What is Gabriel thalamide synthesis? Why aromatic amines cannot be synthesized by Gabriel thalamide synthesis? Next is Hofmann bromamide degradation, where an amide is converted to amine having one carbon less. And basic strength of amines is a very important topic from this chapter. So you have to remember that 3-degree amines are quite basic as compared to 2-degree, 1-degree, and ammonia in a gas phase. Whereas in a aqueous phase, there are different scenario with methyl and different scenario with ethyl, because so many other factors also contribute to the basic strength, like solvation effect, steric hindrance, inductive effect. So subtle interplay of all these decides the acidic strength, basic strength of amines. So in case of methyl substituent, 2-degree amine is more basic than 1 degree, then 3 degree, then ammonia. In case of ethyl substituent, 2 degree is more basic than 3 degree, then 1 degree, then ammonia. You have to know that aniline is a poor base because aniline itself has 5 resonating structure, and the nitrogen of aniline acquires a positive charge due to conjugation, due to resonance. Therefore, it is not able to donate it to the proton. So aniline is a poor base with a pKb value of 9.38, which suggests the higher the pKb value, weaker is the base. So you have to remember the pKb value of some of the amines given in the NCERT table. And then you have to go to aniline, how aniline reacts with bromine water to form 2,4,6 tribromoaniline, which is a white precipitate. How we can protect the NH2 group to synthesize para-bromoaniline or para-nitroaniline. How nitration of aniline is carried out with substantial amount of meta product being formed. This is quite an important question. You have to remember the carbylamine reaction for the test of 1 degree amines, Hinsberg reagent, benzene sulfonyl chloride, paratoluene sulfonyl chloride. These are the reagents which help distinguish between 1 degree, 2 degree, 3 degree amines. Quite an important topic. Then you have to go to diazonium salts, which is quite an interesting topic because only aromatic diazonium salts are stable in solution at low temperature. Aliphatic ones are unstable. You have to know the diazotization reaction, the Sandmeyer reaction, the Cutterman reaction, how benzene diazonium chloride undergo coupling reaction to form yellow dye and orange dye with aniline and phenol respectively. Then coming to a important topic from biomolecule, organic is biomolecules. You have to know carbohydrate, how glucose is prepared, how glucose reacts with bromine water, HNO3, how it reacts with HI under prolonged heating. You have to know the Haworth structure of glucose, what are anomers, so isomers which differ around carbon 1. So alpha D plus glucopyranose and beta D plus glucopyranose are anomers. Which is sweetest naturally occurring sugar? Fructose. So fructose has 3 chiral carbon, whereas glucose has 4 chiral carbon. What is the hydrolysis product of sucrose? Like sucrose on hydrolysis give glucose and fructose. So there is change in the sign from dextro to levo. This is inversion. What is the hydrolysis product of lactose and maltose? So lactose on hydrolysis give glucose and galactose, whereas maltose give 2 molecules of glucose. What are glycosidic linkage? What is the D sugar and L sugar? So this on the basis of glyceraldehyde you have to know. Now coming to proteins. Proteins are the polymers of alpha amino acids. You have to know what are the amino acids, what are the 20 amino acids, whether they are acidic amino acid, neutral amino acid, basic amino acid, or essential amino acid, which are not synthesized in the body and required from outside. There is a trick also to remember it. PBT team hall. Phenylalanine, valine, threonine, tryptophan, isoleucine, methionine, histidine, arginine, lysine, leucine. And there are non-essential amino acids which the body synthesizes. So we don't require the non-essential amino acid because the body itself makes it. Then there is a denaturation of protein when the protein is subjected to like pH change, temperature change, or treated with chemical or radiation. They loses its biological property. 2 degree, 3 degree structure unfolds. Only 1 degree remains intact. So that is denaturation of protein. Coagulation of egg white, curdling of milk. These are some of the examples of denaturation of protein. What are Jupiter ion? So in aqueous solution, the carboxylic group can lose a proton and amino group can accept a proton, giving rise to a dipolar ion called deuter ion. So in deuter ion, amino acid shows amphoteric behavior. It reacts with both acid as well as base. Then come to nucleic acid. These are the polymers of nucleotides. What are the components of nucleotides? Like the pentose sugar, ribose and deoxyribose, nitrogenous base, purine and pyrimidine. Purines are adenine and guanine, whereas pyrimidines are cytosine, thymine, and uracil. Uracil is only present in RNA. Thymine is only present in DNA. The differences between DNA and RNA, deoxyribonucleic acid and ribonucleic acid. DNA is the genetic material of most of the organism, whereas RNA is the genetic material of some of the retroviruses like HIV virus, etc. There are broadly three types of RNA found in cell: messenger RNA, ribosomal RNA, and transfer RNA. With ribosomal RNA is the most abundant RNA present in cell. RNA basically helps in protein synthesis. DNA can synthesize DNA with the help of enzyme. It is called replication. And DNA can also form messenger RNA. The process is called transcription. So from these, so many important questions are can become that like DNA is a double helical structure. The two strands run anti-parallel and they are complementary because in front of adenine there is guanine, in front of adenine there is thymine, in front of guanine there is cytosine with three hydrogen bond. So if you know the strands of one chain like 5 prime, 3 prime, you can predict the 3 prime, 5 prime. So this is based on Watson-Crick base pairing rule. Adenine forms double hydrogen bond with thymine, guanine forms triple hydrogen bond with cytosine. Then what are the applications of nucleic acid? What is the because nucleic acid are the chemical basis of life. What is DNA fingerprinting? How it helps solve so many cases. And other topics are vitamins, like there are two types of vitamins, uh, fat soluble and water soluble. Fat soluble you can remember with a trick, EDEK or KIDA. Vitamin A, D, E, K are fat soluble, whereas vitamin B complex and C are water soluble. Vitamin C is also called ascorbic acid. Vitamin B complex, there are so many vitamins like vitamin B1, B2, B6, B12. Lack of vitamin B12 causes pernicious anemia. Lack of vitamin A causes xerophthalmia. Lack of vitamin C causes scurvy. Lack of vitamin D causes rickets in children and osteomalacia in adults. Vitamin E is called tocopherol. Lack of vitamin E causes sterility problem. So it is also called anti-sterility vitamin. Vitamin K is also called phylloquinone. So lack of vitamin K causes delayed blood clotting or hemophilia-like symptom. So you have to remember the sources of the vitamin and also the deficiency diseases, along with some hormones also you have to study. So this was all most important topics. So you have to know the name reactions from organic, which is very important, the conversions, what happens when, some mechanism based reaction like hydration of ethene and dehydration of alcohol, esterification, SN1, SN2 reaction is very, very important. Elimination reactions, the Satjev rule. So these are the most important topic from which you can prepare. Reading NCERT will be really helpful to you for your CBSE preparation, writing some mock test, keeping your confidence high. Don't waste your time. Believe in yourself and have self-confidence. Keep working hard and you know you will get a very good score in your upcoming exam. So thanks for watching. This is Sandeep sir signing off. All the very best to you for your upcoming exam.